Okay, we're going to learn about like terms. So a like term is that, is this not the next sheet?
It is.
A like term is that they have to have the same variable parts, and that's going to be exponents and all. Same variable part, and that includes the variables have to be the exact same. Okay, I want you to think about a few things here before we get into the actual work part of it. So I want to ask you, 3 times 6, is that the exact same thing as me doing 6 times 3?
Yeah.
Yes, it is. Therefore, would x, y be the exact same math as yx?
Yes.
Okay, does that make sense? 3 times 6 and 6 times 3 are the same. Therefore, x times y and y times x are the exact same. Okay? So there's something to think about. In math, let's pretend, do you guys know what square footage is? Like
Yes.
area?
Yeah.
And linear footage. Can I add 5 square feet and 6 feet together?
Yeah.
No. You can't add area and a line together. That doesn't work. Can you add 5 square feet and 6 square feet together?
Yes.
Yes. Okay? That's the same thing as we're going to be doing here. Okay? Okay, so the first example says identify like terms. Okay, so this has just a b squared. Do you see anything else that has just a b squared with it?
Yes.
No. That's just a b. Is that the same as a b squared? No. Okay, this one has a cb. Do you see anything else that has cb?
No.
No. This one has just a b. Do you see anything else? Okay, so then those are something that's like each other. You could put those together. Okay, in question B, do we see anything that is the same as another one?
Yeah.
X squareds. So that has just x squared, just an x squared, just an x squared, yep.
11 is negative 3.
Okay, in question C, you said 11 and negative 3? Is that what you said?
Yeah.
Yes. Do you remember what these are called when they have no variable on them?
Numbers.
Starts with a C.
Constant.
Constants. This is a constant, and this is a constant. So you can put them together. I'm also actually have something else in this one.
Q. 3P, Q, and QP.
Yeah. I'm going to put boxes around those. So these are like each other, and these are like each other, but I didn't want to use the same symbol because they're not all like each other. So PQ is the same as a QP, right? Just how I said before. What did I say? 3 times 6 is the same as 6 times 3. Okay. You are to make up something. So you have to make up some like terms. So 4x, you just have to make up something that has just an x in it. So you could be like 10x. That's the same. What's that?
105 trillion x.
105x. I don't have room for the trillion.
Can the number be negative?
Yep.
Yes.
You want a decimal? You can be like a half x, like that. Yep. I really don't care what's in front as a number. All I care is that the variable part just says x. Okay, this one, so your variable part has to be p squared and a q. You can put whatever you want in front of that. 5, whatever. Okay, can you also give me another arrangement that would be the exact same?
Q squared plus P or whatever.
I can't do a q squared.
Q plus P squared.
Qp squared, not plus, because what is connecting them? What glues all these things together?
Multiplication.
Multiplication. Okay, so did you see that this still has a q in it and a p squared in it? Okay, and this one here, it's just a number 8. So what else looks the same as just the number 8?
11, 7, 5 trillion.
Any number. Okay, do not put a variable on it. It's a constant, any kind of constant. Okay, and can you find on your own any terms that are like each other in this set? Did you pick those ones? Okay, these are not like anything else. Okay. So, combining like terms. You can only combine things that are the same. So, a 4x and a minus 2x, those are like terms. And there's a 3 and a minus 6. Okay, so I'm going to be putting these together. So everything that I've highlighted yellow, what does it make when you put 4 x's and you take away 2 x's? What do you get? 2x. You had a 3 and then you subtracted 6. Negative 3. Okay, here we go. I'm going to use, since you guys probably don't all have highlighters, I'm just going to use symbols. Okay, 2x squared. Is there any other x squareds that you see? Okay, so those are like each other. So if you have 2x squareds and then you add another x squared, you have 3x squareds.
Oh my goodness, Ash.
Okay, now I'm going to look for other like terms. So there's a 3x and a minus 4x. Those would be considered like each other. So if you had 3 x's and you took away 4 x's.
I don't. Is that negative x because it's x squared subtract 4x?
That?
No, like wouldn't it just because it says in the expression that it's x squared subtract 4x, so it would be a negative 2.
X squared minus 4x? That?
That would be negative.
That cannot be put together. Are you trying to put those together? You can't put those together. That's like putting apples and oranges together. You don't make apple orange. Right? Right? They're separate items. You can't be making them together. Does that make sense? Because those weren't the like terms of each other. So you can't ever put an x squared together with an x. Yeah. I know that you're thinking they have the same letter, but they're not the same thing. Yeah.
For solving the equation, but it's an expression.
It's not an equation. Yeah, you're right. It's an expression. Okay. And then I see another.
So, how much do you think we can make a living off of Oracle juice? Or
Apple orange.
Oracle juice, yep.
Okay, so I'm going to put these together because they are like each other. So if you had a -1 and then you took away 2 more, there you go. That's your answer. Okay. What's like each other here?
X squared, 3x squared.
So I have some x squareds and x squared. So those are going to be put together. So I had a negative x squared and then I added 3 of them. What are you at? Positive 2x squared. I'm going to look at this one next. 2x. I don't see anything else. There's nothing else that looks like 2x. So
Negative x squared plus 3x squared.
2x has nothing to go with it. It's just got to be left alone. So I write it down. Now, this, and this. There's 3 things that look like each other there. So I can put them all together. Ready? 4, take away 5. -1. And then from -1 down 2 more. -3. Okay. There you go. You got 2 on your own. No. Okay, that's a good question. So Henry says, does it matter the order? So maybe somebody did this, like something like that. Good. Yeah. So that was a good question. Order doesn't matter. Okay, like something like that. That's good. Okay. Get me your answers in the box there. All right, let's check out your answers. So if I was to identify like terms, then there's some x squareds and more x squareds like that. So I would put those together. So if I had a -3 and then 1 more negative, I am now at -4 of them. Okay, as I was -3 and then -1 more. Does that seem good? Okay, now to identify those as like terms, so they could be put together. So there was 5x and I took away 2x, which means I'm at 3x. I have to put this plus sign because do you remember the discussion about polynomials yesterday? Polynomials is 2 terms. What is this called when you have 2 terms? It's a binomial. And how do we separate terms? With an add or subtract. An operation. It has to be an add or subtract to separate them. What do we use to tie it together? Multiplication or division ties one thing together, and add subtracts separate things.
So basically, grade 3 destroys and grade 6 rebuilds. Wait, it could be the other way around too because it doesn't matter how many.
3x minus 4x squared. Like that? Is that what you mean? Yep. These are both, doesn't matter the order, right? Okay, why wouldn't order matter? So, is 4 plus 5 the same as 5 plus 4? Yeah, it's all good, right? Okay, and your answer to this one. So there's some k squareds and more. So negative 2 and then 5 makes 3k squared.
3,000 square. Okay.
Then I found another like relationship. So there's a k. How many k's is this right now?
1K.
1k. You had 1k and then you took away 3k's.
Negative 2K. 2K.
Then there's another relationship that can connect. There's a 3 and then I took away 4. What is this called when it has 3 terms? Trinomial. What is the degree of this trinomial? It's a 2 degree because that's the highest exponent.
2.
Yep.